Most welcome to this video. We are going to look at the transpose and inverse of a matrix. Let's go straight to the point. If we have our matrix B given as C, D, E, F, then they ask us to find B to power T. This B to power T here, it is a short form of B transpose, or the transpose of matrix B. Now, when we talk of a transpose is just the opposite of this matrix C, D, E, F. When I want to get the transpose of this, what is a row here? A first row becomes the first column, and the second row becomes the second column. So my B transpose BT equals to, what is a row there becomes the column. I will have C, D. What is a column? The second row becomes the second column. E, F. This is my answer. Then finally, when I am asked to find the inverse of that B, the inverse, when they tell me to find B inverse, B inverse can sometimes be written as B to power -1. This is the same as B inverse, or the inverse of matrix B. I know that matrix B is the same as matrix B is CD, C, D, E, F. Now, when it comes to the inverse, we use the formula. The inverse of a matrix is given as 1 out of determinant of that very matrix B times the adjacent, or the adjoint of B, times the adjoint of B. Now, we know how to find the determinant, we know how to find the adjoint. So when we have the original matrix B equals to C, D, E, F, then finally our B inverse will be 1 out of, determinant is major diagonal minus minor diagonal. Major diagonal is C, F, minus minor diagonal is DE. Then we multiply it by the adjoint. Adjoint we get from the formula. You only alternate the major diagonal, you alternate them. F comes first, then C follows. Then in the minor diagonal, you change their signs. So this is negative D, this is negative E. So this is any formula that we shall use for finding the inverse of matrices. Now let's go straight to the point, and we say given the matrix C equals to 1, 2, 4, 4, 6. Find Roman 1 C transpose, Roman 2 C inverse. I've already told you that this means transpose of C. This means inverse of C. So in our solution, we shall have our C is given as 1, 2, 4, 6. This means when you transpose it, you will find C transpose as what is a first row there becomes the first column. First row is 1, 2, then the second row is 4, 6. This is our answer. So this is the solution for number 1. Then the solution for number 2, which is saying C inverse. Let's go to number 2, C inverse. We know our C is given as 1, 2, 4, 6. So using the formula of the inverse, which is say C inverse equals to 1 out of determinant of C, then times the adjoint of matrix C. So our answer would be 1 out of determinant of C. We find it by saying product of major diagonal, which is 1 times 6, minus minor diagonal, which is 2 times 4, multiplied by the adjoint, which is 6, 1, negative 2, negative 4. When we proceed, we shall have our C inverse the same as 1 out of 1 times 6 is 6 minus 8 times 6 negative 2, then negative 4, and then 1. So we shall finally have 1 out of negative 2 times 6 negative 2 negative 4, 1. So when you are multiplying, we shall treat negative half as a scalar. So it means it will multiply all the numbers inside the bracket. So finally we shall have negative half times 6 is negative, in fact 6 times negative half, negative 2 times negative half, negative 4 times negative half, then 1 times negative half times negative half. So you can see this cancelled by 1, this 3, this one all go 1, 1, this 1, this 2. So our final answer will be negative 3, then positive 1, then positive 2, negative 1. So this is our C inverse. This is the C inverse. Thank you very much for watching.